Hi, I'm an avatar designed by Yili Lin, a health services research PhD candidate at George Mason University. Today's topic, testing assumptions for ANOVA in R. For ANOVA to yield valid results, certain assumptions about the data must be met. We'll concentrate on testing the common assumptions are normality of residuals, homoscedasticity, independence, and outliers. Assumptions ensure that the F statistic and p-values are accurate. Violating assumptions can lead to incorrect conclusions such as type 1, false positives, or type 2, false negatives errors. Independence of observations, before ANOVA, ensure random sampling and avoid repeated measures or clustering unless using appropriate models. Verify that the variance within each group is approximately equal. Levene's tests whether the variances are equal across different groups. If the p-value is less than 0.05, variances are significantly different. Box plots, visual inspection to compare spread across groups. Wide discrepancies may indicate variance issues. Box plots can also be used to check for outliers, visually assess if the groups differ significantly. To check the independence of residuals, look at residual plots and run statistical tests for autocorrelation. Fit your ANOVA model, extract the residuals from the fitted model, and plot residuals to visually inspect for patterns. An ideal residual plot should show no discernible pattern, indicating independence. Durbin-Watson to test for autocorrelation in residuals. The LMTest package provides this functionality. Install and load the package. The Durbin-Watson statistic will give you an idea of whether there is autocorrelation, ranging from 0 to 4. Values are around 2 suggesting no autocorrelation. Below 2 indicate positive autocorrelation. Above 2 indicate negative autocorrelation. Fit the model. Retrieve the residuals and fitted values. Visualize whether residuals are randomly scattered around 0 or if there's a pattern, which indicates non-constant variance. The plot function creates a basic scatter plot of residuals against fitted values. The abline function adds a horizontal line at 0 for reference. The lowest function is used to add a smoothed line to help identify any patterns in the residuals. The Bruch-Pagan test formally assesses if there is a significant relationship between residuals and fitted values. A p-value greater than 0.05 suggests homoscedasticity. If the points on the QQ plot lie close to the red line, the residuals are approximately normally distributed. If the residuals are normally distributed, the histogram should be symmetrical, with most values concentrated around the mean. The Shapiro-Wilk test is a statistical test that checks the normality of the residuals, returns a W statistic and a p-value. If the p-value greater than 0.05, suggesting that the residuals are normally distributed. Points with a Cook's distance greater than 1 are generally considered influential, but a more common threshold for smaller datasets is 4 divided by n. N is the number of observations. Common methods to deal with violations of assumptions. Normality violations can lead to inaccurate p-values and confidence intervals, increasing the risk of type 1 and type 2 errors. Log transformation reduces right skewness. If your dependent variable has a long right tail, taking the logarithm can make the distribution more normal. Applying a square root transformation can also help right skewness. The Kruskal-Wallis test ranks the data and compares the mean ranks across groups. It's useful when your data is ordinal or when you cannot achieve normality through transformations. If homoscedasticity is violated, the F-test in ANOVA may not be valid, leading to increased chances of type 1 errors. If Levene's test indicates that variances are unequal, Welch's ANOVA is a more appropriate test, an alternative to the traditional ANOVA that adjusts for unequal variances. Independence means that the observations in each group or between groups should not influence each other. This is crucial because ANOVA assumes that each data point contributes unique information to the analysis. Ensure that the study design properly randomizes the allocation of treatments or conditions. Randomization helps to minimize the risk of dependence among observations. When independence cannot be assumed, like repeated measures or clustered data, a mixed effects model allows you to account for the dependence among observations. If observations are clustered, cluster-robust standard errors can correct for the potential non-independence within clusters. If you're analyzing test scores of students within different schools, using cluster-robust standard errors can account for the fact that students within the same school may have correlated scores. Before ANOVA, test assumptions related to the data and study design to ensure appropriateness. After ANOVA, check residuals to validate the assumptions of homoscedasticity, independence, normality, and outliers. If any assumption is violated, apply common methods to address these issues to ensure the reliability of your ANOVA results.